Hello, welcome on in everyone. Happy Friday. We're going to be building some AI today. Low ranking adaptation for fine tuning. This is where we use PyTorch, import a model, and then we can fine tune it. We can fine tune it to make it better or to make it follow our new training data. Like we give it more information. The neat part about this is it sounds complicated, but it was actually really simple. I was looking at this over just this morning and I'm realizing, hey, how's it going there, Sigma Edits? Welcome on in. Good to see you. Happy Friday. We're going to be doing some low ranking adaptation today. Have you ever done that? I haven't. We're going to try it out. We're going to try it out today. Let me get the link shared here for our Discord so everyone knows. Yep, we're starting to stream in a few minutes. We're starting right now. You haven't either? Okay. Well, today's going to be the day. All right. So let's go paste at everyone. Here we go. All right, I'm excited. I'm really excited for this because it seems really powerful. It seems extremely powerful. There's also other things. Hey, Crafty Anime, good to see you. Nothing. M&A, what are you doing? What do you mean nothing? Good to have you here. Happy Friday. We made it to the weekend. We made it to the weekend. All right, let's see here. So I've got an example that I pulled up here. And hey, Neva, me sitting down to do some side project. Steven making LoRA stream. Yeah, that's what we're doing. Yep. Yeah. I got an example here that I think we can follow. And it would be really easy. In my head, I've got it. It's pretty straightforward. You just add some layers into the output. One of the essentially parameters, right? You got a couple of matrices, and you take the outputs. The matrix needs to match the outputs from the previous model, and then you can pipe them into a dimension where it has a lower rank, right? A lower rank, and then the output you need to restore the original output destination. Hey, Bonzupi, good to see you. Welcome on in. Happy Friday. We made it to the weekend. Crafty. Oh, you're so tired. Oh, hey, no worries. Hey, can I ask a question? Absolutely. Sigma Edits, what do you got? What's your question? How do you advertise for a product or solution? I find it expensive to pay someone to self-promote. Seems bad. So what should I do? How did you advertise your company at first? Yes, okay, so it's called OPA. This is neat, OPA. It's called Other People's Audiences. Which is, oh, your internet went bad? Oh, it did? Oh, crafty, okay. OPA's approach where you take where other people exist, other communities, and you integrate into them, right? So for example, let's go to PubNub. We have got a PubNub React Native example here. This will get you started using React Native and PubNub. Then we integrate into that community, and then we work with the community to make it better so that way it perfectly fits into their community. That's what we did. Can't even watch live properly. Oh, crafty. Oh, no. I hope everything works out. Hey, Bonzupi. Howdy. Good to see you. Welcome on in. Happy Friday. I've been awake since yesterday, and my internet sucks too. Oh, does it? You guys. Hey, Dreamer. Welcome on in. Good to see you. We made it to the weekend. Wait. What you are starting today? Yep, hold on. Let me get my other PC. I'm going to code with you. Hi, Michael, that sounds great. Yeah, we're going to do some LoRA fine-tuning today. It's actually pretty straightforward. My company is using tags to see % of PRs done by AI. Are they really? Uh-oh. Oh, wait. Ooh, some other music was starting there. Let's see, is that going to start? We're good? Are we good? Are we good now? Okay, we are. Okay. I'm very sleepy. Oh, really? Hey, Alexandra, good to see you. Welcome on in. We made it to the weekend. Hi, dude. Good to have you here. Let's see here. All right. So let's get into it. So we've got an existing model here, and I kind of want to LoRA fine tune it. I think we could model. Let's see, model.py. Here we go. So the idea is, so we've got this output layer here. This is the output layer. With LoRA, you're going to create unbiased additional parameters. So essentially a linear layer without the bias. Self dot LoRA A which is going to be the input. I'll say Laurel in equals torch.nn.parameters, I think. And then it needs to match the output side, which is number of words, maybe, I think. Yeah, is it number of words? 32, yes, number of words. And then you have a rank. So here's the Laurel side of it, low rank adaptation. And then you have to freeze these layers. So basically we need a fine tuning mode. Hey, Dreamer first like, hey, nice, that's great to hear. Loading again and again. All right, I hope it works. I'm lazy Bonzupi. Wait, what? Oh, okay, yeah. How do you mean done by AI? Like you don't like typing a lot of projects? I let AI type it for me. Yeah, that's what we're doing now, isn't it? That's what we're doing these days, isn't it? Is that AI doing a thing for me or not? I don't know. Hey, Mark Lemon, good to see you. Welcome on in. Happy Friday. We made it to the weekend. You're here. You made it. Happy Friday. Mark Lemon, thank you for clicking the hi button. No, Steven, that's wrong. It's a transformation of the weights. Really? Are you sure? The entire point of LoRA is that you specifically don't add layers. So it's... Do you have an example? Because the one I was walking through, the one I read through, specifically was about... So how would it... Okay. So I know you'll have to freeze the there on a model when you're training, when you're doing fine tuning. And then you have some new weights that you have to have something new there, because if the model's frozen, it won't be able to do anything. So there's got to be something new. The entire point of LoRa is that you specifically don't have add layers. Which Linux distro currently? Cruntly? What do you mean Cruntly? Well, for me, I'm running on Darwin, so you name -A. There you go, Darwin. Let's see, my company is targeting 80% of all PRs co-authored or reviewed by Claude Pilot. If you don't hit that target, we let you go. What? That's crazy. Like, at least reading the paper in front of me. You replace a linear layer with a Laurel layer. You replace it. Okay, so you basically make a new one. You train it, and then you disregard the old one. Is that what that is? That seems not like fine-tuning though, right? I'm thinking like Laurel fine-tuning. If I'm gonna do Laurel where I completely replace the model. Right? Hey, Sergio! Good to see you, Sergio! Epic Bloxpo, good to see you. Happy Friday. We made it to the weekend, you guys. You've been using NixOS? What is that? For a past few months, and it's a few years before, using Fedora. Before that, you were using Arch Linux, and before that, I was using Debian. You get Bonzupi, you're using anime all over the place. There is a bias in there. AB, so AB would be start at 0. Yes, I understand that part. So parameters, we go torch.tensor. Torch.zeros. Something like this, right? La 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 la. I think something like that, right? And you're having bias though in yours. You're adding bias. The point of the W is the old weight. Okay, so hold on here. W plus A times B, and then X plus B. Okay. Let me write that down. We'll try it. W, which is going to be linear 2, or I assume, plus A times B, X plus B, which is the input, and plus a bias. Now, is the bias the original bias? And A and B are going to be the new Laurel layers? There's new Laurel layers! I knew there had to be! So, instead of normal fine-tuning, where W is learned, you're adding a change with significantly less parameters, so it's more data efficient. Yes, I got that part. I knew that part. So we're gonna have a lower rank rather than, so let's see, let's say our rank is 8. Use Arch Linux with Hyperland. All right, we're getting some good one. That's a good one. That's like, if you want the most powerful use of your hardware, and you want the most efficient running system, and make it look nice too with Hyperland, What's the difference between Java and JavaScript? Hey, Epic Bloxpo, I remember you mentioned that, right? Okay, so Java and JavaScript are completely separate languages. They're completely independent, right? Java came out first and was an object-oriented programming that compiled to a bytecode that ran in a Java virtual machine. That is its own complete separate thing. JavaScript is a just-in-time compiled language that was originally called Mocha by Brendan Eich out of Mozilla. Through marketing reasons, I believe when Oracle did this, maybe there's some Oracle businessy things that happened, I forgot. They renamed it to JavaScript. So Mocha was the original name of JavaScript. They renamed it to JavaScript because of marketing purposes. It has nothing to do with the actual Java. Slackword. Oh yeah. Hey, how's it going there? What is the stream about? We're going to do some LoRa fine tuning, and Neva is giving us some pointers. Essentially, the point is that you use a small permutation to the existing weights. Yeah, so we've got our existing weights here, right? We got our existing weights, and then we're going to add this little small one, and I'm calling it LoRa in, LoRa out, because I think that makes more sense to me. And then I believe this is going to be rank. And I think these are rand. I think it's rand, rank, and then the output will be the number of words. So it scales it in and out, right? In and out. All right. So I think that's A and B, right? That's A and B. This is A, and this is B, and it looks like this. Yes, B is the original bias. Oh, B is the original bias. Yes. Okay. Got it. Yeah. We're figuring it out. We're figuring it out as we go, you guys. NixOS is a Linux distribution. Oh, got it. Okay. Understood. I never heard about it. There's so many Linux flavor distributions, you guys. Let's see here. I'm catching up with the chats. You guys. Steven, can you please share your code that you are starting for Laurel today? Absolutely. So essentially, normal fine tuning can be thought of as W plus new, X plus B. Okay. For a Laurel, new is a product of two very low ranking matrices. When you say low ranking, does that just mean smaller? Is that what that means? Does it just mean smaller? When we say low rank, why can't we just say smaller matrices? Void is the only one that list I haven't tried yet. Oh, Bonzupi. Okay. So many options available, right? There's so many options. NanArc. Wait. I recommend opening up the paper for reference. All right, let's actually do that. Let's do that. Let's open up the paper, you guys. So let's do Laurel fine tuning archive. Here we go. All right. Is there going to be a nice, pretty... Let's do a PDF here. Okay. Let's take a look. Pre-trained weights. You've got A and B with a low rank. These are input data. Oh, you pass the input data identical to both sides. Oh, so it's got to match the input data. Oh, okay. Wait. Oh, and then we add them together, and it's the new output. Oh, I get it now. All right, I'm getting it. I get it. Thank you. Like and subscribe. Mr. Bumpy Pickle, good to see you. Happy Friday. Welcome in. See, I was right. Woot, yeah, Michael. I thought you would be using different data specific to your use case. Different. It's this. So here, the part that I assume that's, here's the part that I don't think that makes sense to me. All right. If we're fine tuning the model, then we need to keep both things together, because the original model is going to hold all of the previous data that we've trained into it. The new model that's on the side, which is the Laurel, right? The low ranking, the smaller matrices, right? It's just less data, just smaller number of parameters, you guys. Lives over here on the right side. They sit side by side. It's input on either side, rather than just adding a layer onto the bottom, bolting it on the bottom or top. It sits on the side and it works in tandem. So there is extra. Page 4 of the paper is the equation. Page 4, page 4. All right, let's go into page 4 here. It's going to be some fancy math here, isn't it? Some sort of math. Is this it right here? Okay. ABX. Okay. Oh, that's easy. Yeah, that's easy. Oh, isn't that great? Look how simple that is. Oh, that's so easy, you guys. It's like multiple hundreds of years ago. Wait, why we say rank? I don't know. I guess he named it the thing. Hey, right? Exactly. We name all these things some fancy name. It seems really awesome. It seems amazing. You can inference, take AB matrix you started with and just add it to the weights. You just add it. You just do some addition. I'm sorry, it just seems so simple. And it has such a advanced, complex terminology. Low ranking parameterized update matrices. What is this? What are we doing with words, you guys? What are we doing here? Just add it together. Just add. Has anyone tried Aider for CLI against your local LLMs? I haven't. Crow Engineer. Wonder if anyone else has though. But you won't have that original data that was trained. Yep. So you have to, exactly. You'll just have to have, you have to use it with the base model, and you have to include your LoRA layers as well together. You don't get to just throw away the original model, and you don't have to retrain your low rank either with all the original data, which is one of the nice things about this approach. So easy. Too easy now, Crafty. Exactly. Hello, just discovered your channel. Hey, all right. Welcome on in. Good to have you here. Happy Friday. We made it to the weekend. You joined the right channel for software engineering. We're going to be doing some low rank adaptation today. We're going to try it out after watching this stream. I'm trying to be present, but chat, I can't stop myself from coding. Hey, it's all good. That's what we're here for. That's what we're here for. We're here from coding. So the output of LoRA just new weight to the same model architecture. So it's really nice for inference people. It's really nice for inference people. Yeah. Good old inference people. It adds just a little bit extra. It's not free. You can't say it's free because you're doing extra steps, right? There's an extra matrix multiplication. Well, actually, there's 3 matrix multiplications here, right? Your input, A and B, and then it's addition. So that counts as multiple operations to me. No, it is literally free. How? No, wait, what do you mean? Hey, Sequence K, good to see you. Welcome on in. Good to have you here. I'm second year CS focused on artificial intelligence, machine learning. Your content is interesting. I'm looking forward to learn. We're going to learn together because you're mutating W. It's supposed to be frozen though. It's frozen. You can't mutate W. Right? It's frozen. The gradients are disabled. Like you make a new weight, call it N equals W plus AB. What's N? I'm missing something here. Welcome to the fine-tuning universe of madness. Stephen A. Mr. Dungwall, good to see you. Welcome on and happy Friday. We're trying to figure this out. My understanding is that it's just a way to create your own custom LLM without creating and training one from scratch. Yeah. Yes, it is. It's one of the fine-tuning methods, right? So there are several approaches. One is you can just bolt a layer on the output, so that way you add more and you add more weights into the model. Basically, you start with all ones, so that it's a pass-through initially. So that's one option. The other option is low rank, where you have smaller matrices and then you just add them on to the end, right? This is what I'm understanding. And so then H equals weight times, yes. And it can be written as NX. And that N is now exact same size as W. I'm taking your word for it. I don't get it yet. It's not clicking for me. I see in my mind right now, I see extra steps. Or is it the same? So see, delta of weights X is same as equal as this. So it hasn't fully clicked to me yet. but it's not free. See, that's what I don't, exactly. It seems like it's not free. Yes, you're seeing training, which is not free. Oh. Right. Okay. So let's go through the inference is free. Let's ooh, oh, no, that didn't like that. Reload. Okay. Here. So you've got your original model right here on the blue side. Here's the original model, all right? And then over here on the other side, this is our LoRA, our low rank adaptation, which are going to be a smaller set of matrices that's going to take the same input shape and the same output shape. And the resolution here is the rank, which is the lower part, right? So it's smaller. Because in your inference, you change W. Instead of doing sum, basically W, and then you run that. It looks like you're still doing extra steps because it's, right? It's extra steps. So it's WX, right? Versus WX plus ABX, right? Am I seeing it wrong? I feel like I'm seeing... You're saving new weights. So only this right here? Oh, call it N plus. Okay. N is the new output. Here's the problem though. If you do that, the pre-trained weights, don't you still have to pass all of the data that's ever been trained on the original model through? So that way you have because there's only weights here. There's no extra weights anywhere else. You're getting input and output. So N can't be, no. N is the new weight. Where's N here? I see N right here. I do. I see N here, which is A, and B is a vector, or is a matrix with zeros, all zeros. You do not pass all the OG data, right? Exactly, that would be the point of fine tuning, right? You wouldn't need to pass in all the original data. Not that N is just normal distribution. You chose a bad name. Okay. Well, I feel like this makes sense to me. I feel like I understand it. Do you need the original model and the LoRA weights? Like, call it a new weight T. Okay. So what do you keep here? I feel like you need both, because you can't just reintroduce the entire data set to train this model over here. You need both because you're fine tuning, right? If you have both, you're fine tuning. So you can't not throw this away and you cannot throw this away. You need both of them together, or otherwise it won't work. For inference, you need just T. You can compute T. T equals W plus AB. And that is, then for any input X, you do TX. I get that. That makes sense to me. You still have W, and then you have A and B. And you need those in order to make T, right? I know you have TX, which is now your new function. Or your new function. So the point is you just save DXD. You save you can't get W out of T. Well, you wouldn't, right? R? R is rank. It's just a lower dimensionality. It's to say that the matrices are going to be smaller. Hey, Hadar, good to see you. Welcome on in. Happy Friday. Good to have you here. We're currently debating some LoRA stuff here in a way that helps me understand what's going on. I feel like I fully get it. There's just some architectural pieces that are not all the way clicked yet. Our reparameterization, we only train A and B. Got that. Understood. These are frozen weights. Math final boss. Exactly. It, like, basically at inference, you have function that does X. Yeah. So we got our X input, which are our features, our input data. You pass that over into the original model. And then on the side, you have this low rank model. You pass the E features in here. Initially, you'll get zeros out because B is a bunch of zeros. For P and model parameters, PW plus equals LoRA weights. And you save a new model. That new model is the LoRA model. And you only save... Do you still need both? You still need both models, right? You don't save the model. Actually, I think you save the adapters. Yes, exactly. Exactly. Only save the adapter. Only the orange boxes over here. We only save this side. We don't need to save this because we already have that. You need neither. Really? Okay. Wait. Hold on. You don't save A or B or W. Okay, I know you don't save W, but you don't save A or B. N0 sigma 2 is Gaussian distribution, is what I saw that here. I saw that right here. It's trying to zoom in on this PDF. So you get your Gaussian distribution here. And T is just their sum. Okay. You save a new thing that's called T. LoRA helps avoiding catastrophic forgetting, the biggest issue in fine-tuning for LLMs. Okay. Got it. Then how do you use T in this situation to do a feed forward? Where does that come in? Because I get the forward. I understand the forward part. It's just that is there going to be a new kind of forward afterward? I feel like I mostly got it. I'm just not understanding this final bit here. You just feed forward normally. Look at page 4 of the paper for W times and W. Here, no additional inference latency. All right, let's look at this part here. Zoom in. 0. No additional inference latency. Okay, let's read this. Let's read this little paragraph right here real quick. So mean is 0. Yes, I got that. Yes, that makes sense. Initially, it's 0. All right, let's read this. All right. When deployed in production, we can explicitly compute and store. Let me zoom out a little bit here so we can see that a little bit more on the screen here. Okay. W equals W plus A times, or B times A, and perform inference as usual. This looks like what I was thinking it was. I don't see how it's different. Note that both W and B and A are in rank dk. When we need to switch to another downstream task, we can recover W by subtracting B and A, and then adding the B prime and A prime. A quick operation with very little memory overhead. Crucially, this guarantees that we do not introduce any additional latency during inference compared to fine-tuned model by construction. Okay, so we've got that in the paper. It's not clicking yet. There's a piece missing. I'm missing a specific part. The original A is still there. Okay, so we still have the original model. We prevent fine-tuning on the original weights, right? So we freeze the original model weights. We fine-tune a smaller weight through low rank weight. So we add on A and B. Add that smaller weight to the original weight. Okay, so yes, on the output. No, you store that new W and keep that W forever instead of the old one. So here's the problem. Because the promise of LoRA says that you do not need to duplicate the original model, because that would be very expensive, right? So say you've got a big, ginormous large language model that takes up like a 500 gigabytes. If you want to make, 1 million varieties of those fine-tuned models, you don't want to store 1 million copies of that 500 gigabyte model. you only want to store 1 million copies of the little tiny adjustments that you made in Laurel, right? That's one of the promises and advantages of fine-tuning in this approach, is that you can easily keep the original model and you don't modify it at all, but you still keep it and run it. And then you adapt, like you had an adapter onto the side. So Stephen, you're thinking of it as an inference being the sum of 2 layers, but they optimize to have to just one linear layer. Oh, sure. I mean, I assume that's fair. If you're thinking of it like a newer variant where some of it's quantized, then yes, sometimes you add latency, but you can also re-quantize it, and that also works. Re-quantize. Wait, I've heard of quantization. What is re-quantization? Quantization versus re-quantization. Oh, that's not a thing. Did I type that right? Is that a thing? Did I type it right? Re-quantization. Is it worth back to the MSc in AI specialization, or just learn it off the internet? Hey, Hexgrad! Hexgrade. I recommend learning everything on the internet. I just recommend it. I recommend learning as much as you can on the internet. And if that doesn't work, then go to plan B. All right? Because plan A is free. Learn it all on the internet. Start there first. All right, Neva, thank you for the hearts, you guys. Appreciate it. All right, like quantize the existing weight plus Laurel. I don't know if they have a proper name for it. Okay. Learn it off YouTube. There you go. Hey, how's it going there, Rolex? Hey, Rolex, good to have you here. Happy Friday. Welcome on in. We're doing some fine-tuning with Laurel low ranking adaptation, and I'm trying to do it the way I think it needs to be done here. So we've got a rank, we've got our number of words as input, and the number of words as output, right? So our input here, number of words out. And then we use this. Let's see here. Thanks, Mr. Blum. Hey, all right. Good to hear it. And archive. Yes, archive, exactly. It's called Q Laurel, which is the more advanced. That's more advanced. This is just regular Laurel. We've got OG Laurel. Steven, it's LoRA. Oh, LoRA. Yeah. Oh, so, right. LoRA. Low Rank Adaptation. Right? LoRA. Anyway, Steven, optimization isn't that big of a deal for algos. It's just a thing you can do in the end. All right. It's just important as performance of the thing, which is why we use LoRA. Our LoRA. All right. Good to hear it. Let's see here. It's like LoRA, the name, like LoRA from Tomb Raider. Oh, LoRA! Right? That's what I thought it was. That's the way I was saying LoRA, right? From Tomb Raider. Yes! Tomb Raider. I like Tomb Raider. I like Tomb Raider. I like the OG. I like the OG. The OG, guys. Who likes Tomb Raider? Do you like Tomb Raider? Did you play the OG? All right, sorry, Paul. You play OG. Have you played the original? I'm going to type up the code in Discord so it's more obvious why it's free. Thank you. That sounds great. Neva, thank you. I really want to see it. I want to see it. Oh, your speech to text is showing it weird. LoRA? Yeah, it's not exactly, yes, LoRA, like LoRA. I see what you mean. Hey, Bros, good to see you. Welcome on in. Happy Friday. We're doing some LoRA fine tuning today. Good to have you guys here. All right. So this is the way I understand it. So rank is going to be the definition of the middle part of our matrix here. So we've got matrix 1, matrix 2. We'll get A and B, and we're going to do some interesting stuff here. I call it LoRA in, LoRA out, although I feel like A and B is the way they're supposed to be set. You're supposed to say A and B, I suppose, here, based on the paper. A little bit of A and B in the paper. Here, let's go up to the output. All right, so, yeah. And then, what do we save? What do we save? Let's see here. Let's keep going. What's happening today? We're doing good, Broth. Thank you for asking. We're doing some low rank fine tuning. And let's see. We're just kind of reading through the paper so we understand it. Because it is really simple from what I'm seeing. I think it's really simple. What is the base open weight model you're using? Oh, the base model I'm using is just another model that we've been playing around with. Another model that I've been playing around with is our embedding model that we created from scratch. Thank you for the hundreds, you guys. Where did you find those LoRA papers? This is on an archive. This is archive. Here, I'll paste it over here to our Discord link here on our, let's see, our link share channel. There we go. It is right here. And this is just the original LoRA. Just the original LoRA. There is modern versions. I believe a new NVIDIA one called Dora. There's a Dora and there's a Q LoRA. Are you not using something from Hugging Face? We could do that. Do you work with AI ML fields even? Not as much as I want to. Let's put it that way. I have another business. I have a business here called PubNub, where we connect users through live interactive connectivity. So like things like multiplayer experiences, on-demand delivery, sports and media live updates, and gaming, right? So many different things. Also healthcare and telemedicine. So I've got a communication network. And we don't do that much AI, though we are getting into it. We're getting into it. All right. If it's a smaller model, the difference you see after performing LoRA will be quite noticeable, especially if you have a good data. Oh, really? Really? So it works well with large models, but you're saying it works exceptionally well with smaller models. If money were not on the table, right? Oh, you're not using something from Hugging Face. I suppose we could. I mean, we could do something pretty interesting. Something interesting. All right, I was just gonna do this with my toy model here, my toy embedding that we've been making, just to make sure that it still works. I should be able to pass this through, and it should be zeros all the way through. So I want to be able to activate the LoRa part of it, the LoRa. So Stephen, I have it in Discord to make my show the optimization. Okay, you probably put in general. Whoops, 1 second. General chat. Here we go. All right, here, I'm going to copy and paste this into my editor so I can read it a little bit better. Let's copy paste it here. All right. So here we go. PB paste. We can say neva LoRa.py. Okay. Well, it's not really a Python file. Well, it's kind of a Python file. Okay. Someone's been programming in a different language. Okay. LoRa layers. Hey, all right, there we go. Model up parent. Wait. Oh, wait. All right, so you've created A, B for in linear for all right, so modeled up parameters. So wait, there's, how is this where you're not freezing? How are you freezing the original model though? Let's read through this. I'm gonna read through this. Okay. LoRa needs a properly large model to be worth it. Otherwise, not worth it. Okay. I think the embedding model isn't the correct one because we don't have any linear layers. I do though. I do have linear layers only for the training purposes. Obviously for non-training for inference, I removed the linear layers because we only need the embedding. So you're absolutely right. You're absolutely right. This isn't JavaScript. I know, right? Hey, Loons, good to see ya. Happy Friday. We made it to the weekend. It's not real code. Yeah, got that. See, this is the part that I don't understand. This is actually the very first line here. You're referring A and B to the original model parameters. You're supposed to create new parameters, right? LoRA weights contains for P in model parameters. If not weight contains P, continue. Otherwise, existing weight, new weight, and you have P, okay. So this is much simpler. Where's the mat mult? Where's the mult? Isn't there, there's something missing here. I feel like there's something missing. Works well with lower the total number of parameters are cause when you do LoRA, you don't need to tune all of them because you're tuning more percentage of the total weights of the model is small. So you are mutating the original model. Is that actually happening? It's pseudo. Yep, we've got ourselves some pseudo code here, Michael. We absolutely do. My agent on the way. Hey, Loons, great to hear it. Looking forward to it. How do you make subtitle real-time live? Oh, it's right here. We've got live subtitles right for you here. Live subtitles. Join on our Discord. I will paste a link here again on our Discord. Link share. Just click this link and you can add them to your own OBS. So you could put them on Google Meet or Zoom or Microsoft Teams. You could have live subtitles even if you stream on YouTube or any other platform. The Inference, there is no new mat mult. Okay. I get what you're saying. I don't see how, though. He may be using small or tiny whisper model for transcription. Yes, very small. You have 0% left on codecs. Oh, you ran out. You only had 4% and you used it all. My agent making agents almost finished. All 5.5 vibe coded. Nice. That's great. For training, we have A and B, and then we train them alongside the original weights. Sure. We don't do that at inference time at all. Okay. Let me write the proper full thing. Okay. Okay. So we're looking through this. So this must be the inference here. Let's read what you said here. Go back to general. Somewhat pseudocodey, but close enough. This new model has the exact same shape, but different weights. So it is the same cost. Okay, gotcha. Okay. Well, A comma B. This is interesting. Okay. Got move something coming back. All right, sounds good. Sounds good, Loons. See you in a bit. Okay. I thought it was easier than I thought it was going to be. Okay, it seems really simple. Okay. So let's find a model. Here's what we'll do. We'll find a model on Hugging Face, and then we will fine tune it. Let's do that. Hugging Face. Let's find a small model. Something easy. Something very easy. Let's do a very small something. Maybe text generation, like an LLM. Let's do like a really small LLM. Like not DeepSeek, for example, which has got 1 trillion parameters. By the way, you made a list of all the quirks in Block's AI skills. Oh, right. Thank you very much. I saw. Appreciate it. We will address that. Loons, thank you. Loons, thank you. In my personal experience with VLMs, where I have done fine-tuning, they did not improve a lot. I may have been accurate in the process. That's part of the observation. Data is the most important part. Okay. We need, yes, you're right. In AI training, data is critical. Data is absolutely critical. Let me see. Is there like a good, let's see. This is like a 1 billion. What is this? A 1 billion parameter model checkpoint built on the hierarchical reasoning model architecture trained by sapient intelligence from scratch. It's a dual timescale recurrent architecture, 2 transformers. Iterate over the same input of embeddings for so many cycles with additive state injection. This gives effectively unbounded compute depth. Okay, that's nice. Gemma model be a good one. There is so the Gemma model doesn't run on my architecture yet. I've got a Mac. I tried it. We tried to make it work. We tried. I need NVIDIA for it to work well. Smaller, cheap model, make it more accurate use cases. Did you went live stream every day? Yep, we're doing live stream every day now. You got it. At Muhammad. Yes, every day. Every day, you guys. Amzad, good to see you. Welcome on in. Happy Friday. We made it to the weekend, you guys. Also, I don't think you can. It's not open weight in my understanding. Okay, got it, yeah. Hey, Bogateers, good to see you. Welcome on, Bogateers. Here, Steven, I made a less pseudocode version that helps. All right, here we go. Let's copy and paste this. Thank you. All right. So this is, let's do this. Set paste. Okay, here we go. All right, let's walk through this. LoRA layers. So we're gonna get original model. We get our original model here. Model parameters no grad, which freeze original model. All right. And then train LoRA weights, model LoRA layers. This will do an optimization. Do we pass through both? All right, so what is this train here? We need that. We need help. What are we doing today? Bogateers, we are doing low rank adaptation fine tuning. We are learning it from scratch. Did you review the repo? Oh, yeah, I mean, we don't really have one yet. I mean, we kind of do. It's just not ready. It's not ready for anything yet. So where are we at here? Yeah, so this is where I was. And here's Nevis code. So we've got Nevis code. We're currently walking through it right now. So apparently we copy the original model's weights. We just copy them. But where's the rank? Where's the low rank come in at? I think we're missing R. All right, so questions. Where is R rank? And where is, and then, so how, training, how does that, look, I think I understand the training part. And then where do we store, what are new weights? Let's see. Did you review the repo? Hey, Steven, your live streams are inspiration. Thank you. Hey, Mike, that's very nice to say. I appreciate it. They really motivated you? Good to hear it. Software engineering is a lot of fun, right? It's really great. What's the parameter count limit that you can fine tune on your hardware? I could probably be fine with something like 20 billion. I could see. Look, I've got plenty of memory. Well, sort of. I mean, I only have so much memory. Maybe around 20 billion is what we're looking at there. However, I don't want to do that. I think we need to do something that's smaller, like maybe 1 billion. Train is just fine-tuned using the 2 layers. You originally thought about, okay. The new A and new B are depending on R. Yeah, where's R? Rank R. Yeah, see, I don't see where our rank is because A and B need to be reshaped, right? Oh, what about Quinn 3.5, 0.8 billion? Oh, we could do that. Bonzupi, that actually works. Oh, if you can train 20 billion, then GPT OSS. Yeah, we could do that as well, though I don't want to, because we only have like another hour here. So I want to see some sort of results, and I feel like if we do a smaller model, it'll give us more compute for our time. So yeah, I think the Quinn 3.5, 0.8 would work. You omitted R because the point is to show the optimization. Got it. Okay. LoRa layer items. Uh-huh. Existing weights. Where's P? What's P? Where's P at? Where is P? So we've got some weird things here. New weight X equals old weight. Oh. All right, it's starting to click a little bit. So where's new weights at? So this is what we save, is what you're saying. P is the key for the dictionary? Yeah, but you don't have it in this scope. Where did this come from? It's out of scope. Oh, see? There's no P here. Where P at? Where P at? Where P at? Yes, okay, you got it. Okay, so this is the new weights that we save. We save these guys here. Old weight. Old weight is going to be the original model. Okay. And what is P again? Existing weight. Are we literally replacing the last layer in the original model? Is that what this is? Okay, so are we replacing the last layer in the original model? Yes, old weight is the original. Old / old. All right, so we've got our original here. And how does that compare to existing weight? So we get our existing weight. Existing weight A plus B. Oh, I see now. This is pseudocode here, and then this is our old weight. So we've got old, and then we've got our new. And we're replacing. Yes, old weight is the original. Yes, we are literally mutating the weights. Not the last, but all the LoRa layers. What? Wait. No, wait. I know, I understand. So when we do back propagation, when we do the training, A and B are definitely trained. And then, so we train here, obviously, we train here. So A and B are being mutated here, right? We're mutating A and B here during the training, right? Optimizing. And then we do a replacement. We get our LoRa layers, A plus B, and then we just add those modifications to the very last layer. Hey, how's it going there? Automation Effect, good to see ya. Welcome on in. Happy Friday. Sent star for 2 jewels. Hey, thank you very much, Scribble Note. Thank you, Scribble Nook. Scribble Nook, thank you for the star. I appreciate it. Happy Friday. My gratitudes to you, Scribble Nook. All right, so I think we understand the final parts of this now. I think we got it. All right, Neva. Okay, let's walk through it, everybody. Let's lock in. So the point is we train A and B, and then we mutate the final layer. For each LoRa layer, which is there's only 2, right? Only 2, as far as I know. There are only 2. Do the mutation, which is here. Here's the mutation. Right there. Original model. And we are updating something here. Something here. And when we mutate the existing weight, there are many LoRa layers. How many? Oh, So for every layer, there's an AB for every layer. You can have a LoRA layers at the base. You can have more than one. Okay. All right. Okay. I think it's starting to click now. Let's draw it together. Let's draw it together, you guys. Okay. 2. So we got original model. We're gonna do original model here. So this is the original model. Let's see, original model, and then we've got. Let's keep it simple. Let's do our. Then we've got our Laurel here. Laurel A, Laurel B, and we could do another one at this layer here. So this is our low rank A, and then we could do low rank B. So low rank B. This is like the original weights of final layer, last layer. Just to keep things simple. LEYER. Okay. You can have as many as you want. Have as many as we want. Nice. So then we go through this training process where we do feed forward. So then we're going to have original vector X. So this is X here. And then we're going to run feed forward on that as well. Number 5 here. So we've got X going down there. This is going to be BAX. This is going to give us the output. And really, it's more like AB, because B is the output. It's going to match the dimensions of our final layer weight. And that's going to give us some new output here. Where are we? Number 5. And then this is going to create some new final output here. This is during the training process, right? So this will calculate. This is during training. This is our training process here. Sergio, I know, right? This is getting crazy. It's getting crazy. So this will be our essentially our Y, right? We've got 2 Ys, Y1 and Y2. So like Y1 and plus Y2 equals Y. The new Y. Look at general, please. All right, let's take a look. Yes, this is correct. All right, so far so good. So this is the training process. XX, throwing it through, you get, and then you do your loss, and then you only update the weights here in your laurels. And this process here is kind of more like this, like that, okay, down there, and then we do. Then finally, once we do this training, we do back propagation only on this right side of the screen. And you can have multiple Laurel layers if you want. So you can have another set of Laurel layers for each of these other layers that we have in the model, if you want. In this case, we're just doing the last layer, just for simplicity. And then when we're ready, we're gonna save the final layer here to mutate the final layer, and only the final layer. We're only going to do one final layer, like for example. So the final output, let's zoom in over here. Okay, once we're done training, we're going to, let's see here. So let me sort of zoom in over here. After training, we're going to go down here, and we're going to create a new layer. It's called original weights plus AB, wait, hold on. Let me go back to this. Where is this at here? Oh, A times B, okay. Yeah. Plus AB is gonna be the new output. And then this is what we save. This is the new in matrix. Where's bias involved in this? So how does bias work here? Now it's kind of important that you're doing this not just for the last layer, but for a lot of layers. Okay, so for each layer, we have these low rank adaptations for each layer in the model. Got it. Yes, you got it. All right. Now it makes sense. Now I understand why there's 0 overhead. Because yes, you are technically, well, there's one piece missing. There's one puzzle piece missing in the story though. Because the whole point of Laurel, I assume, okay, I think I get it. I think I've solved the final piece. When you're doing low rank adaptation, one of the promises is that you don't have to duplicate a very large model multiple times to get a fine-tuned version of it. What you can do is you can just save the A and B off to the side, and then when you load the model, you can take the original model and then just mutate. So at load time, you will mutate with A and B. So you just save A and B, which is very small, right? The low rank, right? Because it's smaller matrices, right? There is overhead during training. During training, yes. Okay. We've figured it out, you guys. We've got it. Let's see. Namaste, Stephen. Hope you're doing good. Hey, thank you so much, Ann Schumann. I'm doing great. Good to have you here. Happy Friday. What you're talking about is quantized Laurel. So how does that work in production? The trick here is the original W can remain quantized. Yeah, sounds fair. What does this mean? R less than D? I don't know. I don't know. Sergio. So how does this work in production? So my guess is, here's my assumption. So you're going to train these Laurel weights over here. You're going to save those into a separate file. And you don't want to mutate the original model and then store a whole bunch of copies of like a 500 gigabyte model. So if you're going to create a million copies, you don't want to create a million gigabyte, nearly 500 gigabytes worth of data. That does not make sense. So what you would do is you would copy all the Laurel layers, save those, and then when you want to load a fine-tuned version, you load the original model, and you also load the fine-tuned Laurel layers. Then you merge and mutate the original model with your fine-tuning here, and it generates sort of a new model in your memory, right? So you mutate in memory. Hey, that Vasper, good to see ya. Welcome on in. Happy Friday. Good to have you here. In production, when you deploy, you don't even care it was Laurel. Yeah, you wouldn't. I understand that part. There's just one of the promises that Laurel brings with it is that you don't need to duplicate a 500 gigabyte model for every version of the fine-tune that you have. I'm thinking of it like a multi-tenant infrastructure. So Neva, if you want to make a million versions of that fine-tuning, you wouldn't want to store 500 gigabytes times a million. You would only want to store the original 500 gigabyte model once, and then whenever customers need to make a call to your model with their fine-tuning, with their own custom fine-tuning, you would add that mutation on in the model at runtime. Then, once you've loaded the mutation, you can inference for free. So that does all things that we're describing, and you get every single version. Hey, Tiny Rick, good to see you. Welcome on in. Happy Friday. That's funny because Delta Force has Tomb Raider avatar for this season. Her bow and everything except for dual pistols. Oh, wait, we need the dual pistols. You can't get rid of those. Those are OG. Yes, you can also just save A and B separately. Absolutely. Nice. All right, now I've got all my hopes and dreams covered. They're all fully covered. Okay, I guess it means R is much smaller than D. Oh, Sergio, got it. I see what you're describing now. Yes, low rank because it's going to be smaller than the original by a lot. I guess I need to see what that looks like. Yeah, so you would just save the Laurel layers independently in their own file, in their own little tiny file right here. We got a nice little Laurel file right here. That's got all of our Laurel adaptations right here. We got a whole bunch of them. So let's do this. We got A and B. We can do copy A and B. So we got One laurel A and B there. We got another laurel A and B there. And for each of the layers, we've got that. Then we pass that through, feed forward, X on one side, X on the other. We get our new output. Then we do back propagation to train our laurel. And then, after that training's complete, we just go through and save. We just save only the laurel model. Now that's saved to a file. We've got our original model on the left, and we've got our new laurel model on the right. Right? LoRA model. At runtime, we'll load the original weights and whichever fine-tuning instance that we want. We'll mutate that model in memory with the laurel weights. And then we proceed forward, onward with our inference at that point. Even R1, oh wow! Wow, equals 1, that is impressive. I didn't know you could do that. What are we doing today? We're doing some, like in the paper, they used R4. So you can even do R1. Wow. That would be amazing. That's 1/256 the size. That would be really small. That'd be really small. The Vasper. So we are doing some low rank adaptation fine tuning. So we just learned how it fully works. Neva gave us the full walkthrough, and now I fully understand it. The part that I wasn't getting was the disconnect between the original model and where the LoRA model came in at Inference when you're running it in production. We connected the dots though. We got them all. So if we find a really small model here, let's see, I want to do, here, let's do Jiminy. I want to say good hugging face model for testing LoRA with, I want just a good, it should be small. It should be a small model. I want to do this. All right. Yeah, a large language model, sure. Okay, so we do want, that's why it's standard, one that uses PyTorch, so. See, model that uses PyTorch. Also, Llama 3B is pretty decent. That might be nice. I would like that one. So we've got the Quinn library native purely on top of PyTorch. Okay, so I think we're going to use Quinn. There's also a 5.4 mini, highly optimized PyTorch and flash attention. Why it's great for LoRa, around 3.8 billion parameters. You can fine tune it. All right. Okay. How's it going there? Farhan, good to see you, Farhan Faisal. Good to see you. Welcome on and happy Friday. We made it to the weekend. We're currently going to fine tune a large language model. Are you ready? We're going to use low rank adaptation. Vicky, hey Vicky, good to see you. Welcome on in. Happy Friday. Good to have you here. Quinn is pretty decent. You like their work? Nice. Okay, so there is a good Quinn. So let's look for a small Quinn model because it's all PyTorch, right? It's all PyTorch. Let's go Quinn. Search for a smaller, see all Quins. All right, I want a very small Quinn, please. There is a 27 billion, a 35 billion. Smaller, I want smaller. Like around 3 billion. 1 to 3 billion is what I'm looking for. There's a 9 billion. That's kind of a lot. I probably could fit. DeepSeek 4 Flash. Yay, happy Friday, Vicky! Whenever you use to deploy, Quinn is a nice experience. Is it? Nice, okay. If you want a very small one, there is one from Gemma family. See, the problem is, though, it's not PyTorch. I want to do PyTorch. It's got to be PyTorch native. Because I'm going to be running through the layers, I think. If we can do that. I'm going to try to get the model weights. Because we're getting safe tensor, so we should be able to get the weights. So it should be fine. Because Gemma is a different architecture. Here we go. Here we go. I found it. Here we go. This is the one right here. Here we go. All right. So let's see. Is there a way? So let's see here. So is our message input? All right, pre-trained. Okay, auto model text. So this is the model itself. Okay. All right, perfect. This is what I want. Load directly. Here we go, you guys. Here we go. We're gonna do it. All right. So let's make a new folder called this. Here, let's do mkdir fine tuning LoRA cd fine. Okay. pb paste LoRa.py. Okay. cd fine. All right. Let's do Python LoRA. Let's see if that works. It should work. It's partly why you recommend GPT-2. Oh, GPT-2 would have been a good one as well. Thing is maybe tricky. You need to take out the linear layers and actually modify model code. Well, here we won't do. We'll try just the last layer. What if we do just the last layer? There isn't much else you can do about it. You know, open up Quinn 2.5. Hey, the Vasper, yeah. So we're gonna do Quinn 3.5 4 billion. I'm gonna try that. I think that might. Oh, it's 10 gigabytes. Oh my gosh, that's gonna take a minute here, isn't it? It's gonna take a little while. Gemini says it's very small. Oh, Quinn 2.5. Okay, let's take it as so Quinn. Let's see. Let's do Quinn 2.5. Oh, you guys spell it right. 2.5. Okay. Oh, here we go. Here we go. It is really small. Like really, really small. Okay, I like that. I like that. All right. Here we go. Let's try it. Let's try it. It is extra, extra small. And plus it gives us direct access to the model. Okay. All right. So I'm going to just close that really quick. All right. We're going to replace that. We're going to rerun it now. Here we go. Okay. Now it should be, I need to delete this model. It's pretty big. Oh, wow. Look at that. Okay, here we go. Safe tensors, only 1 gigabyte. That's a lot better. That Vasper, thank you. Thank you. That's what I'm looking for. All right. So last layer is only probably not good enough. Move. So we use it. Reuse it. Reuse it. If you're going for just the last layer, you can optimize a lot by pre-computing everything, and then it's linear regression. At that point, forget about LoRA. Just do a linear regression. Yeah, that makes sense. That makes sense. I want to try at least implementing it. We'll see if we can get more than 1 layer. We might be able to. We might be able to. You are a helpful. Okay. I am a system that can help you with various tasks. Available. You are helpful. Available. So this might not be the best one. However, I'm only going to track the loss, so it's not going to be a problem. All right. Here we go. So we've got our X input. We've got our model. Inputs, new tokens, max. Okay. So here's our model. We're loading it in. And then we've got, oh, interesting. 2 device. What is our device? I don't know. What? Hold on. Let's print the device. All right. Print model.device. Oh, it's going to be whatever's on the, okay, got it. So that's just a copy. That's not a problem. Here, let's try it again. You want at least 2 layers so it's actually deep learning? All right, sounds good. What is the objective for fine-tuning it? Do you want it to do? We are just trying fine-tuning. We don't have an objective. We're just going to see if we can make an impact. That's it. Apologist next token, no. Exactly, right? That's easy. Yep, there we go. That's what we're doing. Wait, hold on 1 second. Close that. Did it print out CPU? It did. Okay. So we're running CPU here. Good. Okay. We should probably... What is PyTorch accelerator, current accelerator? All right. PyTorch get current accelerator. There is a, here it is. Yeah, this is what I'm looking for. Current device, current accelerator. Let's see what we got here. Torch that current accelerator. Okay. Let's see if we can get this to run. Although it's already fast enough, but I don't necessarily see that I need to put it on a accelerator. Pad token ID and end of sentence ID for open-ended generation. Okay. I don't know why it's saying that, but all right. I like fine-tuning system. Yeah, I like the fine-tuning stream. Nice, Sergio. Great to hear it. Great to hear it. All right, so here's our accelerator. Print the accelerator. Okay, here we go. I'm just gonna see what's available. It should say MPS. I should see MPS show on the screen. Oh, import torch. There we go. And then rerun that there. Okay. So we should define our LoRa model here. So let's do this. How do we do this? All right, so let's do our class low ranking adaptation, and this will just be torch.mod. Is it model or module? I always forget. See def init self, and then we do super init like that. Double check. All right, so we're gonna have our LoRa low ranking adaptation. See if this works. Also, while I'm constructing this, I'm going to hide these things for now, because we don't need them yet. Actually, what I'll do is I'll do like a fort. We'll just indentate this for now. See model, looks good. Okay, def do nothing. Fast forward. Let's get our accelerator. Put it up here. All right. Okay. Okay. I'm not an expert, but I heard fine-tuning is making a model very good at one specific task and doesn't need a database for it. Yes. Yes, you got it. That's it, the Vesper. Oh, wait, you can monkey patch over original layers to do LoRa training. That's kind of cool. Like if you override forward. Oh! Oh, yeah! Okay. Yeah. I see what you're describing. I see what you're describing. That could be pretty neat. We'd need the original. I think. All right, we'll keep going. We'll keep going. It's probably gonna do something like Wikipedia. That's a good idea. That's a good idea. So we'll grab a Wikipedia page. I'm seeing examples on GitHub. Okay, nice. Yeah, share them. I'd be very curious to see. I'd be very curious to see. Okay. Let's make sure that we're running. Torch dot, not module, it's model. Is it model? Or is it nn.module? Double check. Okay, there we go. Good, good, good. Okay. So I need to create self dot. Let's think this through. I'm gonna do one layer first. I'm gonna do one layer to keep it simple, and then we could try more than one layer afterward. I think I just want to keep it simple first. Isn't Wikipedia easy to scrape and fetch? We can just grab a training data from there. Yeah, I'm just gonna grab one page. I'm just gonna grab one page. Hey Stephen, good to see you. Hey, that's great to hear, Mohammed. Good to have you here. Happy Friday. We're doing some low rank adaptation fine tuning today. All right, so let me check my model here. All right, so I want to inspect this right here. I want to inspect this. Let's take a look at what we got going on here. All right, so let's pull this out. Then we're going to say print model dot parameters. Then we're going to say for layer in model.parameters. M. There we go. Easier just to pick up a Hugging Face dataset and chop it up. Ooh, there you go. Yep, we can just grab a Hugging Face data. I'm just gonna grab like a simple text document. It's just this, it's gonna be very short. It's gonna be very short. What's the name of the song playing in the background? All right, Perry Math. The answer is, it's called Inner Light by Kevin MacLeod. Kevin MacLeod, Inner Light. Inner Light. You asked at the right time because it's just about to finish. Okay. All right, got a new, here we go. Let's do a new poll. All right, have you done fine tuning before? Has everyone done fine tuning here? This is what we're doing right now. Have you ever fine tuned an AI model before? I like the yes, no. I like the less. I like it when it's two answers. It's two possible answers. Okay. So, print layer. See if that still works. Okay. Auto tokenizer doesn't exist. Oh. It's because I commented it out. That's why. Bonzupi, I've trained many artificial intelligence models from scratch and only fine-tune a few at once. Oh, look at that. Oh, I like that. Oh, I'm happy now. I know what's going on. I get this. So we got our models, parameters right there. Ooh, look at that. Look at that right there. So what do we do about bias? Here's my question. What do we do about bias? Do we leave it as is? Do we not touch bias? Never do you know? Thank you for the party poppers. Appreciate it. Never do. What do we do about bias vector? Do we just leave it as is? I think we might just leave it. Just leave bias as is? Okay. Okay. All right, so here's a LoRA, and then we're going to do we need self here? We do. We need self, and I need the model. I want the original model. So we're gonna do a LoRA, and we're gonna get the original model. And then I'm just gonna grab the last layer. I wonder if I could do that here. Let's just try it. Let's just grab the last layer. Let's go -1. If it's iterable, although I might need to throw it into a list. See that here. Oh, it's gonna give me an error because I'm asking for the model. Here, 1 second. Hide that for now. I'm not using it, so that's fine. Okay. Is making a simple terminal chat not considered as making an AI agent? Oh, well, it is. You're right. It is. That is the interface. So a terminal chat is the interface, right? So that's the, what do you call it? The scaffolding, the harness. It's not necessarily the agent itself. When you're building a harness, you will call out and do specific tasks and do certain things with the AI. That is the agent itself. So you need to have it headless. This is a headless agent. It's called headless agent. No UI. It's just input output. The funniest thing you would be make is it dumb AI like no large language models, no deep learning, just if statements. That's original AI right there. You got original AI right there. Okay. So you use Google API. I like the Google API. Nice. Very nice. Did that work? No, so we're gonna have to list this up. We have to list it. Gotta list it up. I think that should do the trick right there. Let's find out. List -1. It's gonna give me the last layer and, ooh, it's pulling it in. Oh, well, that did something that I didn't want it to do. Whoops. Okay. That is very odd. It's giving me every single parameter. It's giving me every parameter independently. What? That's a little bit too much. I want it to not do that. Hey, J-Bro, how's it going there? How do you test run code while building? Oh, you mean like this in the screen? Like on our screen right here? So on our screen, you see that we've got Vim up here in the top side of the screen. And in the bottom side of the screen is a tmux split that is running another TTY. It's just another input here. So in our terminal emulator is Ghosty. We've got tmux and Vim. So tmux is splitting the panes so we can run the code and read it at the same time. You mean -1? Wait. Oh, colon -1. That's probably it. That might be it right there. Maybe. We'll see. Let's see if that does it. Thank you for asking, or thank you for mentioning. I'm not sure. Based on the output that I saw, I don't know if that... Oh, here we go. But it's giving me... I just want the final layer. Just the final one. And it's giving me all of them. So, what if we did just... How do we do that? You know what? I suppose we could do... Can we... -1, 1? Oh, let's try that. -1, comma 1. Fun. Michael, thank you. -1, comma 1. See if that does the trick. Oh wait, I'm an idiot. Oh no, you're good. You're good. I mean, I didn't know either. Got to try it out. List indices. Oh, let's do not a list here. Let's try here. Let's try that because it's a tensor. It's a tensor. Although that is an iterator. So if it's an iterator, that means, yeah, so it's it's a generator, right? Generators are not subscriptable. So what if we enumerate it? No, because that's still a generator. It's a list, just a list. You want -1. I do, exactly, that's what I want. Put a colon after, okay. List. All right, let's try that. Okay. -1 colon, not that way. Oh. A different way? Oh, actually, that's exactly what I wanted. That's it right there. You did it, Michael. That's it. Use yield. Hey, we could use yield. I know, right? Length -1. All right. No, you got it. Yes, we got it. We got it. All right. Hey, all right. Good to see it. Good to see it. So this is the last layer, right? So literally, this is just the last layer. So we could add this logic here into our model, so we get the last layer. All right. So let's see. Get the last W. Call it last layer. I'm just gonna say layer. Layer on the original model. Thanks, Neva. Yeah, thank you guys. This is really useful. This is really helpful. Okay, so now we've got the last layer. Now we need to LoRA ourselves around it. We got to LoRA around it. All right, so we need, I'm gonna say self dot last layer. We'll call this LoRA A, LoRA in. I like calling it LoRA in. It's going to be parameters, torch.nn.parameter. We're going to say torch.rand. We need to understand what the input for the model is going to be, though. So that's part of the challenge. It's going to be something. So we've got our tokenizer here. And I need to see what this is going to look like. New max new tokens, 40. Generate. Okay, so the maximum number of output tokens. That's just going to run it through. So that's not going to be a forward. That's a generate. Okay. Inputs. Steven, just pick up the shape from the parameter of the layer. Oh, thank you. Thank you. Hey, thank you. All right. Self.last layer.shape. There you go, right there. We've got it. Okay. So let's do shape equals shape. Okay. Torch.rand, our shape 0, comma, and then we need a rank. Rank equals 4. Rank. Okay. We got a parameter. Then we'll do a LoRA out, which will be zeros. This will be rank shape 1, right? Is what we want. Shape 1 here. There we go. 1. Perfect. Okay. Okay, so we got a LoRA in and LoRA out there. Weights. Oh, last layer dot weights. Okay, thank you. .weight. Well, are you sure? Because this is a tensor, so it should have the shape here, right? I believe. Do we need the weight? Also want to assert the parameter is 2D. Oh, well, it is 1D. No, it's 2. Is it 2D? Yeah, no, this looks like it's 1D. This is 1 dimension. This must be the bias. Oh, no, you're right. Oh, it's the layer, it's the parameter. Yeah. He's good. Hey, Lions for Lambs. Good to see you. Welcome on in. Happy Friday. All right, so I'm seeing 1 dimension here, which makes me think this is the bias. So what if we did like -2, which would be maybe the actual weights? Because you want a monkey patch, no? Well, I guess if you want to mutate the model directly. So what I want to do is I don't want to directly mutate the model. I only want to mutate it at runtime. So part of the idea of the fine tuning, the objective is that I want to have 1 million variants of the fine tuning, and I only want to save just the little smidgens, the teeny tiny laurels. Mostly avoid the activation. Oh, right. Yeah, we're not doing any activation here. I'm curious about the monkey patching. Would be interested to do an architecture day. I would love to present on your channel. Hey, MTW. That sounds pretty interesting. That would be a lot of fun. Send your details on Discord. Send the details on Discord. I would iterate over layers. Yes. I mean, yeah. Oh, instead of parameters? Oh, okay. All right, one second. So not parameters, layers is what you're saying? L-E-Y-E-R-S? Okay, let's try this. See if that works. Is that a thing? Or modules? All right, so we don't have layers. Did you say modules like that? I know parameters from the AutoGrad tutorial that we did many weeks ago. Oh, hey, here we go. Hey, all right. So this is the actual layer. Features in, features out. Whoa. wait. That seems like a little bit of much there, isn't that? 151,000 output features? Seriously? It is modules, yeah. A bit gray. Wait, what is a bit gray? It's big because your token size is big. Because there's 151,000 tokens. That's what it comes down to. All right. It's a big one. That is a big one. 0.5, 50%. What are we halving up there, Michael? Oh, it's a lot. It's a lot of features. All right, so that makes sense. Here's what I want to do is also, I'm going to go back to parameters really quick, and I'm going to say -2. Just curious about that. I thought it was 0.5 billion. Oh, yeah, in terms of the total number of parameters. Right. So that is also a vector. Let's see here. Interesting. Let's go 3. See what's at number 3. Because hidden dimensions are larger. Yeah. Hidden dimensions is where all the memory is stored. All right, let's go back to modules. Modules. All right, let's try that. So that gets us the layer. See, this is, wait, did I type that wrong? What are your inputs? The inputs are going to be here, right? Right there on the screen. Modulese. Oh, I just spelled it wrong. Modulese. There we go. Okay. Inputs are going to be just a bunch of tokens here. And then we're going to train the model on the output to fine tune it here. All right, let's see here. All right. So you have 4 inputs and got that many outputs. Yeah, kind of. Let me think. So it's essentially the number of outputs are going to be 150. Here, this is why. So 151,000 outputs, right? That's the number of features out. Wait, features out. And technically, that's the labels. In features, okay, that's just the output. All right. So the point then, lines for lamps, this is going to be fine tuning. So we'll be able to train the model to learn new data that it's never seen before. And it'll be better at replicating whatever we're trying to train it. And we're just going to train it like on a Wikipedia article. Your way with layers was cleaner. Like if they have layers, use that. It's so nice. Some people feel like they are too cool for school, and you have to force PyTorch to let you get the thing. All right, it's trying it. I want to know how much letters is there in one token. Oh, you know, I don't know. I don't know. I don't know what their tokenizer is here. So our tokenizer is whatever the tokenizer is. I don't know specifically. I don't know how it splits it. I don't know how it normalizes it. I don't know if it's byte pair encoding. I don't know the specifics. The only thing that I care about is I'm going to wrap the layer, and I'm going to do matrix multiplications, and then I'm going to add the output and then get a loss. So I'm going to assume the model here. So you said, so Neva, you're thinking that was layers or parameters better? I think it's byte pair encoding. I don't think I've seen anything but BPE. Okay. So it's byte pair encoding, which means it's a bunch of word segments. Like a bunch of word segments. For example, it could be like the word parameter would be like para and meter, or me and ter. So it could be like split into 3 tokens. You're with layers? Okay, layers. Okay, got it. Layers. Well, you mean parameters? The only thing is, I guess it's just the bias on the output. So I'm not getting a multi-dimensional matrix is the thing. I'm only getting a 1D matrix when I do that, which is not what I was expecting. Syllable splitting. Yeah, exactly, Michael. You got it. That's exactly what it is. If they were too cool for school, we would be 4 out without the modules. Oh, all right, we could. It would be great if we could. Patience is godly. Let's see. Yep, parameters for sure is wrong. Okay. So modules then. So do modules. And I get the same output. I get like the same thing. No, I don't. I get something completely different. No bias. Okay, this is it right here. Perfect. Okay. All right, so print layer.shape. .shape. All right, let's try that. Okay. All right. I think this is our answer here. All right, so we are going to just grab the first one. There's no shape. What? Is there a size? Linear object has no attribute shape. Why not? Modules give you layers, while parameters gives you the weights. Layers is a lot better. It's a lot better. All right, I like that better. Nice. Okay. So we can also say size, right? Size, this should be a function. Oh, weight. Got it. Okay. W-E-I-G-H-T. E-I-G-H-T. Okay. And let me do dot shape. All right, let's try that. Let's try that. Okay. That has the shape. It's got the shape. Thank you, Neva. Hey, there it is. Look at that right there. All right. We got it. We got our answer. All right, so it's going to be out and in, I believe, right? So our output needs to be the out here. So let's see. Okay. So the shape needs to be inverted. So this needs to be... No, this needs to be 1. This needs to be 0. This will be modules. Yep. -1. Do we list it? Yeah, we list it up. Okay. We get our modules. Now, my question is, can we also... You can also monkey patch over the forward method if you want, which is fun. So, monkey patching is that... I mean, there's... How do we go about that? So I am going to have a def forward here, right? Self, comma x. We are going to have a forward, and then how? Okay. So I do want. Okay, I do want every single layer. I see where our problem is now. For every layer, I do want... Hey, will you post this? Absolutely, Michael. Like the video? Yes, absolutely. Basically do layer.forward equals new fancy closure. Layer.forward. So the forward of the layer. And then we reassign it. So we're overriding. Is that what monkey patching is? We're just overriding the method. Thanks for doing this. Yeah, you're absolutely welcome. Yep. Here, we'll do this real quick. So let's see here. Get status, get add, get init. Here we go. Get add, get status. All right. So we've got a new LoRA. Then we're gonna say get commit. Started low ranking adaptation fine tuning. Tuning. There we go. And then we're going to create a new repo. Monkey patching is overriding stuff you kind of shouldn't this way. Monkey patching is overriding stuff. And you kind of shouldn't do it. I got it. That makes sense. So I'm going to see if I can do it without monkey patching. Do I need to though? Because I kind of do. I need to get the forward from each of the layers. Right? And then we get the final output. The only thing is, what about, we don't need to do we need to softmax it still for the training part? Because we need a softmax for all the tokens. LoRA is so elegant. Is it? It's pretty neat. It's pretty neat. I like it. I really like it. I think for LoRA, monkey patching is the best solution. Okay, so you're saying that we should override all the layer forwards. Okay, so we really should be iterating through every single layer. The only thing is the input needs, when we're capturing the input, we need to capture the input from the previous layer, which makes it a little tricky here. Right, so we've got some trickiness up ahead. If we're trying to do just the last layer, you can save the old forward somewhere if you want the original back later. Oh, right, yeah, that makes sense, yeah. So old forward equals, let's see, you called it self.last layer, right? Dot forward. Got the old forward, and we got the new forward. New forward equals something. I don't know. We could def new forward, right? And then we say do something, and then we say old forward, original forward, right? Like that, and then we just override it with the new forward, and just like that. You just overrode forward, and it calls your new method. with the correct inputs. That's why I like monkey patching. It reduces the chance for bugs. Oh, all right. I see what you're doing there. One second, you guys. All right, where is this? This music is nice. However, where is it? It's called Chance. Here we go. Okay. Getting up to speed on. Sorry, I just changed up the music there for a second. You just That's why monkey patching. Hey, Code Langton's Entropy. Good to see you. Welcome on in. Happy Friday. We're doing some low ranking adaptation fine tuning. How's it going there? What happened to your hoodie strings? Oh, yeah, I got rid of them. Hey, you noticed? They always got in the way, so I just pulled them out. I didn't think for a year I had my hoodie. I never used the strings, and I'm like, these things get in the way. I just got rid of them. You noticed. That's awesome. Okay. Scandalous. I know, right? All right, so this is the basic part of it. All right, so we got our basic part here. Looks better. Yeah, it looks better. It's easier to deal with, and I don't have to like organize them. I don't have to organize them anymore. All right, for those of you who are here, we're doing fine tuning with low ranking adaptation. We're using a Quinn 3 or Quinn 2.5 model because it's tiny, which works out really nicely for, this situation where we're just trying to build up our own low ranking adaptation algorithm based on our help from Neva in chat and the archive paper that describes the process of doing this for each layer. Currently, we're doing the last layer. I'm going to try it with the last layer. I'm going to see if I can get it to work with the last layer. And then, let's see, we need the original weights. So we got our last layer here. We can do a forward pass on that. So I need the inputs from when we do the forward here. Perfect. Okay. So this is our new forward. Can you explain the monkey patching? Well, apparently, it's just overriding functions. I've heard about monkey patching very often in Python because it's, you can monkey patch a lot of things. You can import a library that overwrites some of the capabilities of another library. With monkey patching, what we're doing is we are just overriding the layer's forward pass, which is just another method built into the class, right? So this is monkey patching right here. You're looking at it right there. Essentially, we're just overriding the method. We're overriding the method with our new method here. That's it. It's really fun in Python. Yeah, it sure is. Polymorphism. Hey, Maran, thank you for your chat. A little bit of polymorphism. In this case, it is it polymorphism? Is it? Is this what polymorphism is? Overriding methods from a class? You want to use really old ThinkPad as a nostalgic Linux tank? Hey! Peter Parkour it is? That's what that is? No, it's not polymorphism per se. See, that's what I thought, because I remember learning about polymorphism like 25 years ago. The new method is just assigning the last layer. Yes, that's what we're doing. That's what we're doing here. Yeah, so we got the last layer's forward method right here. The last layer's forward method. Which makes it really easy because now we can get the input. We get the inputs here. Although I'm wondering, does it need to be self? I think it needs to be self, right? So self, comma. It's a new self. It's called model self, right? So we have to do something like that. What would it be if we didn't do that? You would need to build the entire model, I think. So the way we're currently doing it is odd and it's not fully complete. I'm just trying to make it work. Hey, Loons, you're back. Welcome on back. Good to have you back. If we didn't do it this way, what would we do it differently? There is a different way to do it, yes. We would define a forward pass here. right? Which we need to do. Let me think about how to do that. Or we don't need to do it. We don't need to do that. So we're injecting the model in, and then we do need to do a forward. So we're gonna have a layer forward. If we have all the existing layers. I'm just thinking it through. I'm thinking it through. You're biting your lip, are you? Wait, feel free to say anything, but following the path. If you want to take a look. Oh, Michael, what'd you say? I'm putting something in general. So for the stream, hey, Laurel PyTorch. LoRa PyTorch. Yep, we're doing our own. Oh, that's exactly what we're doing right now. Hey, from module. We're gonna do from module the model. Print. We get the whole picture. Range LoRa model X. New model dot merge. So this will merge it and give you the full model. Okay. Nice. So then you can do your back propagation and training as usual here. Hey, we figured it out. I understand it. Now we just got to build it. We just got to build it now. Oh, that's from Nevis. Your mind is above. Oh, sorry about that. Okay. Let's see here. Expand. Okay. LoRa linear. Oh, hey. Okay. Super init. In features, out features. That makes sense. Okay. So that defines that there. This will work if you've got an alpha, which is going to be used to modify the, it's a scale. It's a scale. So you take the rank and you take the alpha and it's going to scale it up. So that when you're doing back propagation, because it's so small, it's very tiny, right? It's very tiny because it's 0 to start. So you need it to learn something and you need to scale it up. You just took like 6 months and 2 support ticket to finally get your stickers. Oh wait, what stickers? Did you see the donated to Mozilla? You did, wait, did you see you donated to Mozilla and it took 6 months to get your stickers? That's very awesome. Yeah, share your stickers on Discord. We are happy we are prior to the monkey patching in terms of efficiency. Oh, were we happy where we were prior to the monkey patching in terms of efficiency? Oh, efficiency is going to be the same either way. I don't think it's going to be a matter. You can monkey patch or not. And monkey patching is actually going to be really nice here in this case because if we're only going to do the last layer, right? Weight parameter. Yep. Empty. And then you've got zeros. Yep, exactly. Wait, there's a bias here. Interesting. I'm not doing bias in this case. I suppose you could. A, B, self A, right? Empty, zeros. Wait, where's the bias being used? Self bias parameter. Y. Is that being used somewhere here? Frozen base. So you've got your base parameters. Okay. So this only works for one layer. This works for one layer, which is what we're doing right now. Merge weights. The original weights. A times B times scaling. See, I told you there's scaling. I told you. It would have to have scaling. You put a photo in the donator. Oh, and already on general? Oh, I gotta check it out. Okay, I'll have to check it out. Forget the code. How's it going there, Eminem? Good to see you. Welcome on in. Happy Friday. We made it to the weekend. Forget the code. Show us your skincare routine. Oh, okay. Yeah. You just wash your face. That's all you gotta do. Wash your face. Wash it every single day. You look even tighter, bro. All right, Eminem. Thank you. Appreciate it. If anything, monkey patching would be slower. But like you're using Python, you don't care about CPU. Yeah, exactly. Yeah, exactly. Do overlap point? Okay. Put a photo. All right, let's check out real quick. You said you put the photo in here? Where's it at? Where's it at? Oh, here. Very nice. Mozilla Foundation Donor 2025. Nice. Very nice. Praneeth, welcome on in. Good to have you here. Happy Friday. Okay. My camera kind of bad. Sorry. Hey, no worries. We can kind of see it. We can kind of see it. Okay. Let's keep on going with our LoRA. And you know what? We'll probably want to continue this tomorrow. We're not done yet. We're gonna spend a little bit more time on our low ranking adaptation fine tuning. And the way I'm kind of going through this right now, I'm kind of thinking. Get our module here. All right. So I think this should be fine. Do we want to? I think it's important that we do this. The only thing is, the problem here is, where's the activation going to occur? What's going to happen with the activation? I suppose it doesn't matter. Will the activation still occur if we do monkey patching like this? And if we don't otherwise, how are we going to get every single layer to work properly if we scale it up to all the layers? You put a sticker? Okay, let's see. Hey, make good tech again. Very nice. Mozilla, you got the sticker. You may want to treat the original linear layer as a buffer and not as a parameter, so it won't be turned on considered for gradients. Oh, right. I think steps and in terms of time sunk in, the activation layers still do the forward. The activation layers still do the forward. If you monkey patch, yes, you do have to activate. You do have activations. For the layer itself, so if I'm only capturing the layer, right, just the layer itself, the linear layer, the forward pass that's defined in the model itself will still capture, right? You'll still get a capturing of the activations. Yeah, you're capturing the linear layer that didn't anyway do any activations. So the original code did. So the original code will still activate, or it won't anymore. Also, if there's convnet here, activation linear forward X. So the original code did. Right, so if we're doing monkey patching on the linear, the original code still does activation. Nice, okay, that's what I thought. Okay. So we can do this. Let's see here. We could put this in a for loop if we wanted to. If we're only doing the last layer, and then we do the forward, then that means that we can capture the forward on the input and the output. And then we just run forward on the model. Will this monkey patch it? Let's try it. So we get the model. We're going to monkey patch it. We're going to get the last layer. We don't really care about the old forward. We're going to do, let's see, last layer dot forward. Hold on a second. You're doing, Steven. How are you doing? Oh, we're doing good, Silky. Good to see you. Happy Friday. We are currently doing low rank adaptation fine tuning, which is actually pretty straightforward and simple, though implementing it, we're working through it right now. That's the part we're working with. That's the major point of monkey patching. It doesn't break any other parts. Nice. All right, now, but you've convinced me. This is the way that we're going to do it. This will be the way. To forward. Okay. So we got our parameters. I'm going to move this to just a little bit lower. There we go. Okay. you. All right, then I want to delete that, and we say self dot rank. We'll do a rank, and then self dot alpha equals some sort of scaling. I mean, you can do either add train the last layer or do like a few epochs on your data. Don't know what the low level fine tuning means though. It means low rank, right? Low rank, which just means smaller. That's all it means. You know, have you thought all these fancy AI terms? They all mean very simple things. With fancy, they gotta have the fancy terms. It's not really a last layer thing. Yeah, exactly. It's an every layer thing. I'm just doing the last layer just for simplicity right now, and then we'll enumerate all the layers, which we'll do here, right? We'll enumerate all the layers. Low rank isn't that fancy. It's first one year of college. Yeah. A lot of these things, I'm like, very often I'm like, well, that seems like it's too simple for the terminology that has been granted. It has been designated terminology that is very fancy, and yet I feel like it didn't quite deserve it. Peter Parkour, are you learning? We are learning. You are learning together. We're learning together. This is great. It's like rank is linear algebra. Yeah, it's very simple. Very simple. All right, so rank. We got our in and out. This is just the first one. This is the first layer. Let's see. And then we got our shape, which is going to grab us the details there. Then I'm going to override and monkey patch the forward. And then our forward will need to take the model weights and do a dot product, right? So then we just do our x at self dot, let's see, last layer dot weights dot last layer dot weight. Can we do that? That's the output. We just say return. So this is just a pass through, right? Return. I think that's it right there. Simple pass through. Map is isometric by definition. If we choose the fanciest terms, just scare people up from us. Yeah, we gotta choose the fanciest. Oh, wait, there are other terms? Like objective homomorphic map is an isomorphic by definition. We just choose the fanciest terms just to scare people. That's what I thought. That's the whole point. You scare everyone away. You make it sound prestigious. And an echelon. Unreachable, unobtainable. That level of knowledge is so fancy. Don't ever expect that you can make it. Isn't that crazy? It's this AI, you guys. All those fancy math terminologies mean simple things. Sounds fancy. Really isn't that fancy, right? I mean, I know matrix C rank haven't done whatever Steven is doing here. Soki, yes. It seems fancy. It's really not. Where this is just going to be used for the low ranking, the smaller matrix C, right? Small, teeny tiny. And then the alpha is going to be used to scale it back up on the other side when we do a forward pass. That's it. So this is just a pass through. Simple pass through here. Neva is that returning correct? I think this is just a pass through, right? This is not yet. We're keeping it simple. We're keeping it simple right now. I don't know if we need this anymore. So I'm just going to get rid of that. And this isn't a module. I think it'd be fine if it's a module. Do we need it to be? I don't think so. In fact, it doesn't even need to be a class. I don't even think this needs to be a class. It could just be a LoRA. LoRA. And then we just monkey patch. There we go. So now we can just monkey patch it. Hey, MD, good to see you. Welcome on in. Happy Friday. So Greg Hartman talking about Rust and Linux kernel. Ooh, hey, there we go. I think you can just search it on the internet right now. If you want to really, really want to know. I kind of curious about it. I'll have to watch it for lunch. Stack Overflow did. Have you guys been over to Stack Overflow recently? I bet you haven't. You guys want to go see what's going on over at Stack Overflow? StackOverflow.com. Hey, Stephen Blum, what did you learn today? I'm sorry, Stack Overflow. I'm one of the 100 people that visited you today. I feel really sad. What do you got going on over here? What do we got going on? We're visiting Stack Overflow. Check this out, you guys. One variable programming. Okay. Stack Overflow. You could just make it functions. Python doesn't care. Making it functions. Can we run it? Yeah, we can. Here we go. I'll run it. I don't know if it's going to work. Let's see, where are we at here? Python LoRA. Here we go. And it shouldn't crash, maybe? No, it's going to give us an output. There we go. Okay, perfect. All right, so let's do this. Let's do it. So we are going to run our LoRA on our model. Should it return the model? We don't need self anymore. So we got to get rid of self and super. Self. We don't need self here. No more selfing. Last layer. There we go. Okay. Pass through. Does everything else look good? Nope. Gotta fix that. Okay. So this will just modify monkey patch. It's gonna monkey patch the model. Okay. And then we're gonna run it. We'll run it for you. All right, we'll run it. Lions for lambs, we'll run it. It's not gonna do, we haven't done the fine tuning part of it yet. This is just setting up for it. We might do that tomorrow. Let's just see if we can get through part of this. Last layer, shape, rank, alpha, LoRA in, looks good. Def, forward. All right, so we got our forward pass here. And we're gonna overwrite it. Looks good. Accelerator, tokenizer model. Then we're going to return the model. Return model. Right? Model, modules, layer. Okay. I think we need to do that. Last layer of the model. Okay. And let's see if that works. We should also print it worked. To confirm it, right? We got to confirm that it worked. All right. New and bad at GitHub. Oh, hey, that is why I have an empty Git repo. All right, sounds good. Have that tutorial on how to add Git to my projects. Really easy. It's really easy. You can make code more readable by leaving spaces between functions. Yes, that's what I do. I kind of do that, mostly. It's here. We don't need parameters to print anymore because we already got what we wanted. Okay. Let's double check that. Okay. Make sure that we're still working here. And then we're going to say our model is going to be monkey patched with model. Pretty sure that should do it. And then we should see, we didn't do any forward path yet, but let's at least try to run it first real quick. AI discovering kernel bugs very frequently right now. Oh, really? Really? List object has no attribute weight. What? Oh, okay. 1 second. Where are we at here? We need this. Here we go. That's right here. We got it right there. It's the same thing. It's the same thing. Oh. Maybe do 0? I'm not sure. Hold on. Wait. I've got an idea. Here we go. Yeah, so we'll paste this in, and then we're going to set the last layer to the layer. Like that. And then we are going to say, break. Get the last layer. All right, this is a temporary, very temporary. Get last layer. Can we print out the X times last layer weight? Yes. All right. That'll be as far as we go today. That's a good idea. We'll do it. X at last. Let's see. Forward. Out equals. We return out. We say print out. There we go. Actually, let's do this. So we can so we see it a little bit better, a little bit easier to see. Okay. All right, there. We are printing it. Now that's just the forward. So let's see here the rest. So I'm gonna hide these for now. No. There we go. Do you guys at PubNub ever monkey patch, or is it generally a big no-no? We don't monkey patch. Nope. In fact, when we had Python, which we've replaced with Rust because we've gotten so big, our data files just too much. It's too much. So we had to upgrade to Rust. However, when we had Python, we might import some. We used to import with one of our code bases a module that did monkey patch some of our code. However, that wasn't our doing. We didn't do that. So, yes, we've done it before. Do we do it today? No, we don't. We don't do it today. Okay. Is that going to solve the issue, what you think? With Rust? I think so. MD, I think Rust is going to help. I do. I think Rust will help. Okay. Let's see if we can at least get this to run. Okay, so far so good. Linear object has no attribute weight. Did you mean weight? Yes, I typoed it. Okay. La 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 la. There we go. Okay, we're making our way, you guys. We're monkin' patching on the way. Can we print out the X at last? Wait, yes, that's what we're doing right now. With monkey patching, you can just do the for loop on every linear layer and it would work exact same way. Exactly, yes. Speed in Rust, a lot bigger than Python. That's why we did it. You want to try Rust, but people make something called a bow checker seem like a monster. It's actually fine. The only thing that I don't like about Rust is having to manually manipulate lifetimes and any of the complexities that you have along with generics. I can do them. I can deal with them. Do I want to? No, I don't want to. However, I can eventually get used to it. I can. Hey, there it goes. All right, it didn't crash. Perfect. Okay, so let's do a forward pass now. Let's see if our monkey patching took. All right, let's try it, you guys. Let's try it. Let's see if we did it. Let's see if it works. Think for the party poppers. Appreciate it. Uh-oh, we got a problem here. Missing one required positional argument X. Forward, missing one required positional argument. So we need to define it. It's right here. Maybe it's just X. Well, see, the thing is, with the forward pass in a class, it's going to require self to be defined, right? Oh, wait. Hey, it worked. Or did it? Mat1 and Mat2 shapes cannot be multiplied. Oh, good. Okay. At X. Let's try that. Have you ever tried Zig, Steven? Hey, Bon Zoopy. I have not tried Zig. I think I kind of would like to, though. Why is that not good? That is so close to exactly what it should be. Let's see here, you guys. And 10 million of those tokens were cached. Wait, look at the previous message for context. Okay. Loons on Codex. You used around 11 million tokens for the free tier. It's great. You love wasting big AI corporations' money, all of them except for Anthropic. That's a lot of tokens for free. That really is. That's a lot of free tokens. But it's because I made everything be identity based, so everything is copy. And I don't care. That's okay. Exactly. Clone it all. Clone everywhere. It's not memory safe, but it also doesn't have any hidden control flow or undefined behavior like C. Unsafe in Rust would, though. It sure would. Sentence encoding in nutshell. Why is this not good? It's so close to what it should look like. I know, right? Bogateers? Exactly. Yeah, it's very C-like. All right. So what I want to do before we wrap up here is let's get this very final bit here working. We need this last part working here. For whatever reason, that shape isn't working for me, and I don't know why. It should. Never, we need some help here. I know, right? Lions for lambs. Almost. I mean, you can see right here. This is very close to what we want it to be. Do we need to transpose on one of these guys? .t. Am I doing this right? I don't. Maybe we do transpose. I think we do. Okay. Hey, look at that. It worked. We did it. We passed it through. Okay. Now we can get our Laurel training going. Look at that. We did it. Hey, it worked. All right. That's what I'm looking for. See right there. No errors. No errors right there. See? You can see it right there on screen. Woo, we did it. We did it, Lions for Lambs. Zig Devs said no hidden control flow. It's got to be all on the surface. No escape. It's got to be verbatim. Let's train it. I know, right? Let's chain it. I really want to. I do got to get. I got to get going though, because I've got other work to do for Friday. We will be back tomorrow though. We'll be back tomorrow, and we'll be doing some low ranking adaptation fine tuning on the Quinn 2.5 model. Quinn 2.5 model right here. Quinn 2.5 model right there. We're gonna do it tomorrow. Estelle, how much time of learning and practice I need to make it what we're making now? Well, it did take me quite a while to get on board with the AI stuff here and understanding the pieces. My recommendation is building your own neural net from scratch to sort of understand the initial basics. That's the good stuff. All right, guys, good stuff. Good never. Compared to Rust, yeah. Compared to Rust, Zig mostly just doesn't have macros and no destructors. Oh. We did it. This so makes me happy. All right, we'll be able to finish our Laurel fine tuning. We will. The low ranking adaptation. Just look at Zig Dev word for at face value. You just took Zig, right? I know, right? We just assume. It's easy to assume. That's the way Zig was. We just assume. Thank you very much for the stream. Very informative. Yeah, Bogateers, thank you. It was really great to learn this LoRa fine-tuning today, and I was surprised at how straightforward and simple it was. Now that we've got the basics and the understanding, we've got a single layer, the last layer. Obviously, with LoRa fine-tuning, we need to do all the layers, and we will. We'll grab every single layer. For now, we're just doing the first one, and this is just what it looks like. And essentially, we're monkey patching the original model. This is going to allow us to leverage the same inputs and outputs for this layer. And then we are going to train this, and then we're going to sneak out the output. We'll sneak out the output into a separate model. And that's the plan. That's what we're going to do tomorrow. All right, you guys, thank you so much for joining today. Had a lot of fun. Let me commit this code really quick. All right, so git status, git add, git commit with 2 M's. Thank you for the party poppers. We have the pass through working. Need to get ABX next. All right, that's the plan for tomorrow. Git push origin main. There we go. All right, you guys. Basically what DeepSeek did to Anthropic in small, right? Yeah, they did some distillation. All right, so I'm going to paste the repository. Where did I put it here? Oh, wait, we didn't make one. Git status. We didn't make one. Hold on. Let me make a Git repository, and then I'll paste it on our Discord. So if you guys are interested in following along, you can. New repository. There we go. All right, so this is low ranking fine tuning. Here we go. All right. Using the Quinn 2.5 model to fine tune using low rank adaptation adaptation. Perfect. All right. Public create. Then I'm going to copy and paste this into the terminal, and it is live. There you guys go. Here's the LoRA. I'm going to paste it into Discord under link share, and we're there. We're good to go. All right. Bye, Steven. Hey, Loons, Neva, Bonzupi, Bogateers, that Vasper, Estelle, and Lions for Lambs, and all the viewers. Thank you so much for joining. We're headed out now, you guys. Good to have you here. Thank you. We're wrapping up. RuneScape. Ooh, you want OG RuneScape? Hey, bye, everybody. You should remove the blocks AI text. Oh, right. Because, yeah, exactly. Thank you, everybody. Good to have you guys here. We'll be back tomorrow, about the same time tomorrow, and we'll continue with our low ranking adaptation fine tuning. Bye, everybody. Thank you for joining.